Hello Legacy students, this is Miss Mar speaking. Today we're going to look at linear or not, which is on linear and nonlinear functions. You're going to want to have a notebook, a pencil, and maybe a calculator. So the video is going to focus on how to identify and represent patterns that describe linear functions and nonlinear functions. So some vocabulary first that we need to cover. So a linear function is a function that goes up or down by a constant amount. So it's always going to go up or down by 2. Let's say that. Now, the graph of a linear function is a straight line. So it's always going to look like that. It's never going to have a curve to it. And it cannot be a horizontal line. It can not be a vertical line. But it can be a horizontal line. Now, nonlinear functions, this is a function that does not go up or down. Go up or down by a constant value. Now, this graph is not going to be a straight line. Usually these are going to have curves in it, or they're going to look like a V, or they can look like an S. There's a bunch of different ones that they can look like. So let's look at this first problem. They say graph this function and then say if it's linear or nonlinear. So I need to graph this on my coordinate plane over here. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now I only needed to go up to 7, so I'm good. 0, 1 is my first point, so I'm going to put a dot there. 2, 3, 2, 3, next point. 3, 4, next point. And 6, 7 is my last point. Now, if I connect all these dots together, whoa, that's not a very good line. There we go. Notice how I have a straight line. So if I have a straight line for a graph, you can say he is a linear function. Let's take a look at this guy. So I have to see if it's linear or nonlinear. So just like last time, I'm going to label my axes. Go up to 8, go up to at least 8 on my y. Alright. 1, 4 is my first point, so I'm going to go 1, 4. 2, 1 is my next point. 3, 0, my next point. Then 4, 6, 1. 6, actually that should be 4, 1. My mistake. There should be a 4 there, not a 6. That should be a 4. So if you look here, if I draw in my curve, you see how it kind of makes almost like a U shape? We're going to learn more about them as the year goes on. But this one is non-linear because he's not a perfectly straight line. So let's take a look at this one. They say this set of ordered pairs represents a function. We don't care if it's linear or not. We just want to see, can we write that rule? So I'm going to first make myself an XY table and fill it in. So I got 2, 10, 4, 20, 5 and 25, 7 and 35, and 9 and 45. Now I need to find if this is a linear function. That kind of lets me know what I'm looking for. So I'm going to start seeing here. I got 10, 5, 10, and 10. Now if you look here, this 5, it's between a 4 and a 5. So they changed my x value for a moment there, which is fine. That can happen. Oh, that should be 2. So then, let's just kind of not even look at that. It looks like each time I go up by 10 on my y's, I go up by 2's on my x's. So I can make that, and if you look at that, that's by constant amount. So I know I have a linear function. So I can start my linear function. Now, my m is always going to be my difference of my y's over the difference of my x. So that's going to be 10 over 2. If you remember, to find our b, we need to find what 0 is on our x. So 1, or 0, because I'm going to go down 2, right? That is going to give me 10 away. So I'm going to have a 0 for my answer. So I get y equals 5x for my answer. Let's take a look at this one. So I'm going to, just like last time, I'm going to create my xy table. 0, 0, 1, 1, 2, 8, 3, 27, 4, and 64. Now, if I create my search seeing, I go up by 1, up by 7, up by 19, and up by 37. Now on this side, you see how I'm going only up by 1s each time. Now, I'm not going up by a constant amount by any means. So I know I have a nonlinear function. Now, nonlinear functions are a little harder to write the rule or the equation for. I always like to look at them and see how are these two numbers related. So I kind of look at this and I say 2 and 8. How can be 2 and 8 related? Well, I know that 2 times 2 times 2 is 8, so that would be like 2 to the third, right? That equals 8. Let's see if the rest of them work out. So 3 to the third. So that would be 3 times 3, 9 times 3. Oh, that's 27. We're close here. Let's see. 4 to the third. So that would be 16 times 4, and that is 64. So I got 1 cubed, that's 1, and of course 0 cubed is 0. So it looks like I stumbled upon my nonlinear function. Y equals x cubed. Let's take a look at the last problem for tonight. So I'm going to create my XY chart just like you're going to. Got a 2 and a 5, a 3 and a 10, 4, 17, 5, 26, 6, and 37. Now, if I look at this, I'm going up by 5, up by 7, up by 9, and up by 11. It looks like I'm going up by 1s each time here. So that's not a constant amount either. So I got a nonlinear again. So I need to figure out how are these numbers related. So how on earth could I ever make 2 into 5? So if you kind of look here, I start thinking maybe it's squares, maybe it's cubes, and I kind of look here and I see 2 squared, that's 4. So that's 1 more gives me 5. So let's look here. 3 squared is 9. Add 1 more, ooh, that gives me 10. And that looks like that's my pattern. So I got 2 squared plus 1 gives me 5. 3 squared plus 1 equals 10. Looks like I'm on a pattern here. 4 squared plus 1 equals 17. 5 squared plus 1, that gives me 26. Oops. And 6 squared plus 1 is 37. So it seems I stumbled upon my equation, or my rule. So y equals x squared plus 1. That's the end of the video. See you later, Legacy.